You may or may not remember, but we started actually in chapter 2, and then we worked our way up to chapter 4. We just finished chapter 4. We're going to be beginning chapter 1. So we're going clear back to the first of the book. This chapter is going to be super easy because we've already done 2 through 4. So it's just going to deal with different types of graphs and situations than a parabola, but they're very similar. If you remember, the vertex form or the graphing form of a parabola looks like this. A x minus h squared plus k, where hk is the vertex and a is the scale factor. Okay, we've been doing this quite a bit. That's how we would graph that. If you think about graphing it, how would it look? Well, if I think about it, I would say, all right, let's have an equation, let's say f of x equals, let's say a half, and then x minus 3 squared minus 5. How would that look? Well, I would start at not negative 3. A lot of kids make that mistake. Realize it's h in the h in the equation is the opposite value of h outside of the equation. Watch, negative h to h, right? So I don't want to go to negative 3. I want to go to what? Positive 3, and I want to go down 5. So this point, 3, negative 5, is my key point, my vertex. From there, I should go over 1 and up a half, over 2 and up half of 4, which is 2. How did I get the 4? Remember, I'm just using the parent graph. So that's how I would graph this. So I'm going to go over 1, up a half. I'm going to go over 2 and up 2. And then 3 and up like 4 halves. So this is going to kind of arc out a little bit. It's going to arc out that way a little bit. So it's a little bit wider than the original. That's what that one would look like. We've been doing a lot of those. We've done a lot with quadratics. We've done everything you can think of with quadratics. Now we're going to go back and look at some other types of equations that are similar. Well, the one we're going to look at today is the absolute value equation. Okay, so we're going to graph some absolute value equations. Sorry, adjust this just a little bit. Okay, so the absolute value equation we're going to look at, for its parent graph, is just f of x equals the absolute value of x. So think about this. Again, we're getting values of y by plugging in values for x. So we're just going to do that on a little t-chart, just like we did with the parent graph for the other one. So think about that. If you're at 0, you're at 0. If you're at 1, you're at 1. What's the absolute value of negative 1? Oh, it's 1. What's the absolute value of 2? 2. What's the absolute value of negative 2? 2. What's the absolute value of a half? Half. What's the absolute value of negative a half? A half. What's the absolute value of 3? 3. What's the absolute value of negative 3? 3. And so now I graph all those on a graph. Over 1, up 1. Over 2, up 2. Over 3, up 3. Over negative 1, up 1. Over negative 2, up. So an absolute value is going to V up, not arch up. You can see this has a little bit of arch to it. It's arching up. While this one doesn't have any arch, it's just a straight V. So these become V graphs. Okay, for our parent graphs of for all graphs that are absolute value. Now that V can narrow or it can widen. What do you think is going to happen if the A value is greater than 1? So again, our equation we're going to be using for these is A absolute value, x minus h, plus k. Now it's not squared, it's just in absolute values. So still hk is going to be the vertex. And the A value is still the scale factor. However, that scale factor is going to make this V be either narrower or wider. What's going to happen? Well, if it's greater than 1, it's going to be what? Actually narrower. Because you're going to go over 1 and multiply it by a value of 2. So you're going to go up 2. If 2 was the scale factor, if 2 was the A value. Over 2, and instead of 2, 2 times 2 would be 4, and that would get narrower. Okay? Now, if it's half of 2 would be 1, that's going to get wider. So if the scale factor, so if A, the scale factor, if A is greater than 1, it will get narrower. If absolute value of A is less than or between 1 and 0, which means it's a fraction or a decimal, it will get wider. Okay? Now, what does it mean by on these little ASCII? What's the vertical translation and what's the horizontal translation? Well, vertical translation is translation what? What does vertical mean? Up and down, that's right. So we're going to translate the graph up and down. So the k value in these equations represents the vertical translation. The horizontal translation is right or left, horizontal, across the horizon. So the horizontal translation is that h value. Remember, it's opposite of what's in the equation, though. Okay? And that's what we're going to do as we do these. So, for example, let's say I was asked to graph -2 absolute value of x plus 3 plus 4. Okay? What would that do to the vertex? Well, instead of 0, 0, which is where I would normally start, I would go left 3, opposite value of what's in there, -3. So what's in the absolute value? Opposite value. Opposite value, or the value that would cause this to be 0, really. And then on the outside, we end up with 4. So that is my vertex, over -3, up 4. Now from there, I would normally go over 1 up 1, over 2 up 2, over 3 up 3, over 4 up 4, over 5 up 5. We'd end up with a v, right? But the problem is our scale factor here is -2. So I should go over 1, and instead of up 1, I got to multiply these values by 2. So I'm going to go, or sorry, by -2. Okay, so I'm going to go over 1, down 2, over 2, down 4, over 1, down 2, over 2, down 4. So I end up with this a little bit steeper v than the other one because I have a negative, it's opening down. Now how do you describe the graph? This is what it's going to ask you to do, is to describe the transformation from the parent graph. Well, I would say, okay, we have a horizontal shift, that means right and left. We went left 3 units. We have a vertical shift, that means up or down, up 4 units. Vertical shift up 4. We reflect it, that's the negative in front. We reflect it across the x-axis. We're making it open down. So I often would just say open down there, but if we're really describing it, it's been reflected across the x-axis. And then it's been multiplied by a factor of 2. So the negative is right there. And then once we've made it negative, we're going to multiply it by a factor of 2, all the parent graph values. All right. Now, here's a weird one. There's one thing that's a little bit complicated. We never really did one of these in our parabolas, but it would work the same way, actually. What happens if you have a number inside the absolute values, but it's in front of the x? So not in front of the absolute value, like the -2 was, not an a value that's on the outside of the absolute value, but one that's inside the absolute value. Well, we don't want that there. We want there to be just an x for it to be in vertex form. So how do we get rid of the -4? Well, the best way to get rid of the -4 is to factor it out. But you can't factor it out of the absolute value right off the bat. You have to first factor it out of this equation. Factoring it out means you divide it out. So I'm going to factor out a -4. That means I'm dividing both these terms by -4. So what's -4 divided by -4? That gives me the x. What's 2 divided by -4? That gives me the -1/2. Now I have absolute value of -4, and then parentheses, x minus 1/2, close parentheses. Now can I bring that out? Well, you can, but what is the absolute value of -4? Well, the absolute value of -4, the distance to -4 from 0, is 4. So I'm going to put that on the outside as a positive. So when you bring a negative out, it's going to be a positive. If it was a positive under here and I brought it out, it would still be a positive, because the absolute value of a -4 is the same as the absolute value of 4 Either way, you're going to have 4. It's going to be a positive value when you bring it out of the absolute value. Now it's in vertex form. Now I can graph it. I can do all kinds of stuff with it. So I'm going to graph this one. Where is my vertex point? Well, the horizontal shift is right half. The vertical shift is down 3. Right a half, down 3. There's my vertex point. 1/2, comma, -3. From there, my scale factor is 4. So instead of going over 1 up 1, from the half, from the vertex point, don't start at 0, 0. From here, I'm going to go over 1 and up 4. Over 1, up 4. And I can keep doing that, both left and right, by the way. So I can go this way, same thing. Notice I'm still at these half marks. I'm between these two marks because I've gone over 1 from a half. So I'm at -1/2, -3 halves, positive 3 halves, positive 5 halves, so forth. Okay, that's all I do. And how do I describe the translation? Now this time, they may have some of these on here that want you to describe the translation from a given graph. So it may say, hey, compare this to the graph of f of x being x plus 2. What's the translation from this graph to this graph? Well, that's still pretty easy. You just say, well, where's my starting point on this graph? Well, my starting point on this graph is -2, 0. So to get from -2, 0, how would I get to 1/2 and -3? So when it asks me to compare to this, I think about the translation from that vertex point to this vertex point. So horizontally, how far do I move from -2 over to +1/2? I've moved 2.5 units right. If you think about that, here's -2, I move 2.5 units, that puts me at the half. And then I want to move vertically 3 units down. I went from 0, I went straight down 3. How did I get the -2, 0? Well, I just took the vertex of this equation, of the one I'm supposed to be comparing to. And then I compare that to the vertex that I mapped. And then what happened? Well, this one doesn't have anything in front of it. Its a value was 1. So this one I need to multiply by a factor of what? What's the a value here? Multiply it by 4. And that's how you do that. Okay? So that's how you'll do those questions. Let me see if there's any others that I want to go over. I think that's it. So let's turn to your book. We're in section 1.1. So we're very first chapter. So I know that's kind of weird because we kind of went backwards, which is fine. We wanted to do that. That was intentional. So we want you to go to chapter 1.1. And I want you to do problems 5 through 41, 4K, 4K plus 1. Problems 5 through 41, 4K plus 1. Remember this problem right here. This is going to be the trickiest and hardest one. When it has an a value, but the a value isn't on the outside, don't assume the a value is -4. I've got to factor that out under the absolute value and then pull it out front. Okay? And when I pull it out front, it's going to become positive. So this is the trickiest one on trying to find the a value and put it in vertex form. So pay attention to that one. That'll help you on some of the other problems you're going to have on set 1.1. Do problems 5 through 41. Thanks.